Let's consider how a client can become a member of a multicast group. Notice on screen we've got a couple of laptops, and they're running different versions of IGMP. Now, IGMP, that's the Internet Group Management Protocol, not multicast protocol, it's management protocol. Specifically, the laptop on the right is running IGMP version 1, and the laptop on the left is running IGMP version 2. And IGMP is the way that these laptops can say, hey, I want to belong to a particular multicast group. That message is going to go up to the router, R1 in this case. And let's say that R1 is configured for IGMP version 2. That's going to make it backwards compatible with version 1, so it's going to work with both of these laptops. But let's consider how the behavior is different. And also, switch SW1, it might be enabled for IGMP snooping. And IGMP snooping allows that switch to eavesdrop in on those IGMP messages coming from the client saying, I want to join a particular multicast group. So the switch knows when it receives traffic destined for that multicast group from the router, it knows exactly which ports out of which to forward that traffic, only to the members of the multicast group. Now, IGMP version 1 is going to go up and say, hey, I want to belong to a particular multicast group. Let's say it's 239.1.1.1. But with IGMP version 1, if that laptop decides it no longer wants to belong to that group and it no longer wants to receive traffic, it doesn't tell the router. It just stops talking. It's almost like when you're at a party and you leave without telling the host goodbye, thanks for having me. That's what IGMP version 1 does. So after a period of 60 seconds, that R1 router is going to say, hey, do you still want to belong to 239.1.1.1? I haven't heard from you in a bit. So the big characteristic of IGMP version 1 versus version 2 that I want you to know is that version 1 does not proactively leave a group when it wants to leave the group. And that's different with IGMP version 2. It's much more polite. It's going to tell the host, thanks for having me, I'm going to now leave the party. And here this laptop is saying, I also want to join 239.1.1.1, but when it no longer needs to belong to that group, it's going to send a leave message saying, I want to leave that group. And that's going to allow the switch to stop sending traffic for that group out of the port connected to that laptop on the left. And if there are no more receivers on switch SW1, that's going to allow router R1 to stop sending traffic down to SW1. And with both IGMP versions 1 and 2, when these receivers say that they want to belong to a group, they send what is called a star, G message. The star represents the source sending traffic to that group, and the G represents the group address itself. Well, a star, G message doesn't really care who the source is. We're just saying, I want to belong to a group. But there are times where we may want to specify the source. That's called source-specific multicast. Maybe we have a content distribution network, for example, around the world, and we want to receive traffic from a source that's closest to us. Well, what we can do with IGMP version 3 is use an S, G message, where we don't only say I want to belong to 232.1.1.1, we're saying I specifically want to get traffic from 10.3.1.1, video server 2 in this case. That's the big distinction between version 3 and the prior versions. And if we are using a source-specific multicast, then with IP version 4, that multicast group address is going to begin with a 232. If we're using IP version 6, that source-specific multicast address range is going to begin with an FF3. Now, that 3, if you recall the format of an IPv6 multicast address, that is our flags field, and the binary bits that give us a 3 indicate that this is a source-specific multicast address, and the X represents the scope. For example, is it link local? Is it site local? Is it global? And one of the things that made this IGMP version 3 join message unique is that it used an S, G message. Not only did it say I want to belong to a specific group, it said I want to receive traffic from a specific host. And in an upcoming video, we're going to discuss something called an RP, a rendezvous point. That's going to allow the last hop router on the way to a multicast group member. It's going to allow that router to determine the optimal path to get back to the source being used. Because originally, we don't know who the source is. But with IGMP version 3, we can know the source. And that can eliminate the need to have a rendezvous point. And if we are doing source-specific multicast with IP version 4, we need to be using IGMP version 3. And if we're doing source-specific multicast with IP version 6, then we need to use a different protocol called MLD, Multicast Listener Discovery, specifically version 2, and that's going to do the same job for IP version 6 as IGMP version 3 did for IP version 4.